Hello students, and welcome to our online lecture today. So we weren't able to cover all of Chapter 4 the other day in class because of all the announcements we had. So I wanted to go over a few things in Chapter 4 before I jumped into Chapter 5. And then at the end of this recording, I'll also give a little discussion for lab. So if you do not have lab on Wednesday, then feel free to stop once I finish the slides. I'll make it really clear when that is. And I'm sorry I did not have the time with the baby arriving to be able to find and create different activities for you to do for these things. So unfortunately it is just a YouTube video and other YouTube videos that I will have you go to that you can find the links in these PowerPoints so that you can get some extra material. Alright, but let's start off with some things in Chapter 4. So we talked about third variables or confounding variables, the fact that when you're looking at a causal relationship, sometimes there could be other variables affecting that relationship. So we have online tutoring to increase math grades, and that's what you're hoping will increase the grades, but it could be other variables that are causing the increased grades. For example, perhaps online tutoring is actually more related with parent help. So people who are getting online tutoring, their parents are like, oh, you do need extra help in math, and it's actually that parent help that increases the grades of the students. So that is one third variable that might be causing an effect. So if we were only measuring online tutoring and increased grades, we would see a relationship there, but in reality it would have been going through this parent help variable. So another example, you could have something like online tutoring, and it might be dependent on computer literacy. This is an example of a moderator. So the moderator relationship between online tutoring and grades, the computer literacy will make the tutoring more or less effective. So the online tutoring will be most affected for people who are computer literate, so it's affecting this relationship here. So, and for people who are in online tutoring who are not computer literate, they will not see as big of an increase in grades. So again, that is what is called a moderator, whereas this parent help, this would be called a mediator. So it could be mediating the relationship, or it's going through the relationship, it's playing a role in the relationship in a different way. So your book describes those in a little more detail, but basically what you need to know, mediator is like this triangle, and moderator is kind of like this upside down T. So, but there could be other variables in this problem. So we have our online tutoring that we think that's going to increase grades, but maybe things like teacher support and school resources, maybe those are much bigger or more important variables to increase grades. So by using experimental control, we can narrow down which variables are most important. And so to make sure that the causes come from what you think it comes from, you need more experimental control. So if you think that the online tutoring is going to be the thing that causes the increased math grades, you need to be able to control for things like teacher support and school resources. Or perhaps make sure everybody has the same school resources and everybody has the same teacher support. So with that, if those are both the same, so if everybody has like a level 8 out of 10, on both school resources and teacher support, then you can be sure that it really is your online tutoring that's causing that change. Alright, so one way to control experiments is just like that example. It's when all other variables are held constant in an experiment. So basically they're not allowed to vary, so they are no longer variables. So that example here, the only thing we're varying is the online tutoring. You either get it or you don't, and everybody has the same teacher support and everybody has the same school resources. That way you can pinpoint that it's not a change in teacher support because everybody had the same teacher support. It's not a change in school resources because everybody had the same school resources. But the only thing that changed was the online tutoring, whether you had it or didn't. That way you can pinpoint that online tutoring is the cause. So that's what I'm talking about when I'm saying experimental control. Alright, so another way to say this is that if all students have the same computer literacy and they all have the same teacher support and the same school resources, we can be more sure that the online tutoring in these examples is causing the increased math grades. So if if everybody has the same computer literacy, maybe you give everybody a computer literacy class first so that everybody's the same, or maybe even better, make sure you're only analyzing data from people who are at least competent on computers. Same with teacher support and school resources. You would measure maybe only students of one school, so the school has the same resources for all students, and maybe even for one teacher, or maybe only teachers who had the same teacher support scores. So that way you could pinpoint that it was the online tutoring that was causing the increased grades. All right, and so one other way to do that, rather than actually hold them constant statistically like that, is through randomization, like we talked about. So if you are assigning people to groups randomly, so if you're assigning people to the online tutoring and the no tutoring condition, and people have different levels of school resources and teacher supports, those differences should be randomly distributed and cancel each other out or negate each other. All right, so now talking about definitions, these are things that'll come up later on. Independent variable and dependent variable. So in these examples that we were just talking about, we have the online tutoring and the increased grades. The independent variable is the one that you manipulate. It's the variable you think might be causing the effect. So that's the IV or independent variable, and that would be online tutoring. The dependent variable is like the final outcome that you're measuring, the variable you're measuring at the end. So it's dependent. The reason it's called the dependent variable is because you think it's dependent on what the independent variable does. So you can think of dependent variable as like the final thing you measure. So in this example over here, you have 3 possible independent variables. They can all vary, and if you were manipulating them yourself, they would be independent variables. And then dependent variable is the final measurement, and that's increased grades. So that's just some definitional things that will come up many times in the class. So be sure you get that down, read the examples in the text as well for independent and dependent variables. All right, so I'm going to jump over to chapter 5, and we will talk about some reliability. All right, so here is chapter 5. You should have all these slides as well. So there are a few videos that I'll mention that you should go to during the course of this video. Just click on the link. So we're going to start off with just talking about reliability. So before I mention that, here's some announcements in the notes, and I'll go over these in class the next time we meet. So a reminder, Wednesday the 22nd is our first exam over chapters 1 through 5. So there will be a review in class, so in the class section before that. So make sure you've looked over the study guide, bring your own questions, make sure you're prepared when you come to that review so you have questions to ask. There's also a TA review section on Tuesday the 21st, 2:15 and 5:45. So the room is to be announced. Hopefully we get a note on that soon. All right, so we're going to talk about validity and reliability, but right now we'll focus on reliability. We'll talk about validity more on next Monday. So consistency or replicability is the way you think of reliability. We talked about this a lot. So is the survey acting the same way each time you use it? Is a measure acting the same way each time you use it? Is it being consistent? Is it producing stable, consistent, or replicable results? All right, so here's some examples. These 2 measurements are reliable. So this is a thermometer that works. This is a scale that works. So with that, these are 2 other examples that are unreliable. You can see this thermometer is broken and this scale is broken. So they would not give you a reliable result. It wouldn't be consistent every time. One time you step on the scale, it might say 140. Another time it might say 20 pounds. So you want a consistent measure in all kinds of measures you're taking of human behavior and cognition and memories, all those sorts of things. So any kind of fluctuations in your measurement indicate measurement error. So what I mean by that is that anytime you take a measurement from this scale, from a temperature, from a survey, you're getting an observed score. That is what you get. So let's say you have a mean score on a survey of purpose of 5.5 out of 7. That is your observed score. Your purpose score is 5.5, and that is what has been observed. Part of that score is true score, so your real purpose score, and part of that is measurement error. So the less reliable something is, the more measurement error it will have. The more reliable it is, the less measurement error it will have. So here's an example of a purpose scale. So these are actual items that I created for a purpose measure, measuring purpose in life. So you answer these questions on a Likert scale from strongly disagree to strongly agree. I know it gives my life meaning. I strongly agree. My life has a clear sense of purpose. I strongly agree. Those kinds of things. So you get an observed score. Let's say it's 5.5. Part of that score is your true score, is a score of purpose. But part of that is measurement error. And actually we found that these two lower questions here, because they're two-sentence questions, so they're kind of double-barreled, brought a lot of measurement error in because people might agree with the first part but not the second part in either of these. So it brings more error in, so our observed score has a bigger amount of error. Where what you always want to do, your observed score, you want it to be more about true score, their true purpose score, rather than measurement error. You can think of this example for IQ as well. So you observe an IQ score, let's say of 110. Part of that score is your true IQ score. Let's say your IQ really is, in reality, 106. So those extra 4 points are actually measurement error, some problems with the test, some unreliableness in that test. So you want to shrink that measurement error as small as you can get. So you want to make sure that the observed score is getting true score and not error. So if your real IQ is 106, you want your test to tell you that your IQ is 106. So you want no measurement error or very little measurement error. So true score, the real IQ score, will be replicable. It will be repeatable. You should get it multiple times. So, but a problem arises because we can't actually measure the true score. So we get only this observed score, the IQ score of 110 or the purpose score of 5.5. We only have this observed score. And we know that it's made up of a true score, but also measurement error. The problem is we don't know how big or small that measurement error is. So what can we do to see if a measure is reliable, if it has very little of that error? Well, we can test it. We can use different types of reliability tests. So test-retest reliability, internal consistency reliability, and inter-rater reliability. And so that's what we're going to focus on for the next few minutes. Starting with test-retest reliability.